Okay, here's a little extra factoring. This is from the pages that we got in class for the extra practice after test B. I just wanted to do a couple problems with no leading coefficient, a couple problems with leading coefficient, and a couple of our GCF and difference of squares. So here we don't have a leading coefficient on number 16. I'm going to do 1 times 24 is 24. And I want two numbers that multiply to 24 and add to 10. Everything's positive here, and 24 has a lot of factors. And remember, you can do all of this in your calculator. So you would just do 24 divided by 1, divided by 2, divided by 3, divided by 4, divided by 5. 5 is the only one that does not work. It's going to give you a decimal, so you're not going to include that in your list. Now, which one of these pairs adds to 10? Everything's positive, so it's 4 and 6. So we're going to take 10x and change it into 4x plus 6x. And I'm going to bring down that x squared and that 24. And then I'm going to cut it in half. My first two terms have x in common, and I like this visual for myself. That x squared just becomes a single x in the parentheses. That 4x, the x's cancel, just becomes a 4. You always have the same sign down here as you had up there in the middle. Since that's a positive 6x, we're going to have that positive down there. 6 and 24, we know 6 goes into 24. I have an x left. 24 divided by 6 is 4. Factored form of this quadratic is then x plus 6 times x plus 4. And then in order to find our solutions, we're going to take each one of those little baby equations and set them equal to 0 and solve. So I'm going to subtract 6, and I'm going to subtract 4. All right, if you would, please pause. I'm going to go ahead and write out the answer for number 18. Pause and try number 18. I'm going to pause and write out number 18. So it's just going to show up out of nowhere for you to check your work with here in about 20 seconds. So go ahead and pause and try number 18. All right, there's your solution for 18. Negative 5 and negative 8. Hopefully that one went well for you. I'm going to go ahead and go on to a problem with a leading coefficient. If you need to pause and hang right there for a minute and look through the work, you're going to need to pause your video for that. Okay, with a leading coefficient, let's go down to 28. It's a little more interesting because it has some negatives going on with it. I'm still going to do a times c, but here it's 3 times negative 5. So 3 times negative 5 is negative 15. Two numbers that multiply to negative 15 and add to negative 2. So my factors of 15 are only 1 and 15 and 3 and 5. So to add to a negative 2, I'm going to do positive 3 and negative 5. Make sure you check those positives and negatives in Desmos for yourself or in your calculator. Play with them, make sure they work. So I'm going to break up my negative 2p into 3p minus 5p. And now I'm going to roll. I have 3p squared plus 3p, so I can take a 3p out. When I take that 3p out, just be really careful. Here, my 3's cancel, one of my p's cancel. With 3p over 3p, that's going to be plus 1 there. So just be careful. I need to bring down this negative in the middle. Negative 5p minus 5p, it doesn't just have 5 in common, it has negative 5 in common. And that's how we get to p plus 1 instead of just p or negative p minus 1. And now to get our variable all by itself, there's our factor form. Now we're going to set each of these equal to 0. I'm going to do the easy one first. I'm going to subtract that 1 over and get p equals negative 1. Then I'm going to add my 5. And divide by 3. Now remember, when you check that on Desmos, you're going to get a decimal there. Just do 5 divided by 3 and make sure your decimal is the same as 5/3. All right, that's 28. I'm going to do difference of squares real quick for you. Remember, for difference of squares, we're looking for that perfect square situation. X squared is x times x. 9 is 3 times 3. X squared is x times x. 49 is 7 times 7. So make sure that before you do difference of squares that you have that situation there. If you don't know if you have a perfect square, double check it. 49 is a perfect square because when I take the square root of it, I get a whole number. 36 is a perfect square. 35 is not. So if you see a 35 in your problem, you're not looking for a perfect square, you're probably just looking at a GCF. So that's a really good quick check. And then we have our pattern. X is going front. The square root of your number goes in back. 1 positive, 1 negative. And then you can solve those guys. Same thing here. X is going front. Square root of 49 goes in back. 1 positive, 1 negative. And you can just switch those signs. We had one more factoring situation on the unit test, and it was GCF. I thought I snagged a GCF problem or two. And it looks like I didn't. Hold on just 1 second. Really quick GCF reminder for you. This is number 34, same page. I know this isn't a GCF because if I try to take the square, I know this is a GCF problem because if I try to take the square root of 7 or 21, I get a decimal. So I'm going to look at the smallest number and see if I can take it out. And 7 does go on to 21. So I can take a 7 from both numbers. And since both terms have an x, I can take an x. 7's cancel. X squared divided by x is just an x. My x's cancel. 21 divided by 7 is 3. And then you can still, since this is multiplication, set both of these equal to 0. This 7 times x is what you're undoing here, so we're going to divide. 0 divided by 7 is something that your calculator can handle for you. And then we're going to just move that 3 over. Just some quick factoring reminders for you. Hopefully those are helpful. Good luck on testing.